Good morning, boys and girls, and welcome back. Mr. Mortara here with another day of rational exponents. All right, today we're going to talk about our operations with rational exponents, and we're really going to combine the first 3 days of this unit, kind of all into one day. So let's start with just a little bit of review here, and let's talk or just quickly review our properties and rules with exponents. There's a lot of exponent rules again today, like there were in day 2. All right, so a quick reminder here as you just kind of look at this. When we multiply bases, this is the first one up here. When we multiply bases, the base always stays the same, and you're going to add exponent. That's our product of powers property. All right, our next property is when we take the power of a power. When I take an exponent and I raise to an exponent, then you are going to multiply your exponents together. And again, the base always stays the same. These next two properties, I always kind of think of together, the power of a product and power of a quotient property, which basically just says that if you have stuff inside parentheses, you need to raise all that stuff to the power. So if I have a times b inside of my parentheses, then I can raise the a and the b both to the nth power. Or if it's a dividing by b, multiplying, dividing, doesn't matter. You're going to have to raise both those things to parentheses. We often think of this like the distributive property. However, we're not technically distributing. Okay, it is slightly different, but you need to raise everything inside to those powers. That's what you want to think about. All right, we previously just talked about our first property was when you multiply bases, you add exponents. Well, when I divide bases, then I'm going to subtract exponents, and that's our quotient of a powers property. Again, all these, the base on these always stays the same. Can't emphasize it enough. The base is never going to change when you have an exponent. We just play around with the exponents. All right, and then moving on. When you have a negative exponent, that is going to send it to the other side of the fraction bar. So if it's a negative on top of the fraction, I got to put that over 1 right there, then it's going to send it to the bottom. All right, if it was a negative exponent on the bottom, then it would send it to the top. Okay, the negative exponent just lets you know that it is unhappy where it is at. And my favorite property is the zero exponent property because anything then to the 0 power is 1. And that becomes real easy. You just got to know that, 5 to the 0 is 1, 3 to the 0 is 1. Anything to the 0 is the first is 1. And then our last property we need to review, which we talked about yesterday, is the rational exponent property. And again, what this one is saying here is when you have a fractional exponent, right? The bottom number on the exponent, the n, the bottom number of the fraction, is the type of radical you have, and the top number is the power. And again, we can write it like it has right there, like that, or we could write this as, the nth root of a all raised to the nth power. There are the two different ways that we could write this, and both those things all mean the same thing. All right, and depending on the problem, we'll use both and or either one of those in this section here. So these are all the exponent properties that we're going to be comfortable and familiar dealing with. We will also talk about some radical properties and read those along the way. But before we jump into doing some problems with this stuff, let's quickly do some fraction review as well. All right, going back to like last unit when we talked about fractions and rational functions, when we go ahead and we add fractions together, we got to make sure that we have a common denominator. So I generally set up my new problem like that, and I think, okay, now what is going to be my common denominator? What is the smallest number? What is the smallest multiple that both of these will go into? And hopefully in this case, you're going to say, oh, that's 20. I would have to multiply the 4 times 5. And if I do it to the bottom, then I have to do it to the top. So 5 times 3 is 15. That is my equivalent fraction. And on the other one here, to get a common denominator, I'd have to multiply 5 times 4. So a lot of times we say, hey, we'll just multiply by the, multiplying by each other, and that frequently gets us a common denominator. Not always the lowest, but it will give you a common denominator. But if I multiply 5 times 4, then I can multiply the 2 times 4. Got to do the same to the top and bottom. And so that gives me 8 over 20. And now when we have common denominators, you can add across the tops. 23 over the bottom stays the same. And then you would try to reduce. In this case, I cannot reduce 23 over 20, so I would leave it just like that. All right, next one here. All right, on B, when we are multiplying fractions, remember back from last year, and again, we do not need a common denominator. What I would do with the 6 is I would give it a denominator. And now when we're multiplying, you have to multiply across the tops and across the bottoms. And even the last unit we talked about, hey, sometimes if you can, it's convenient to cross-cancel or cross-kill. All right? Well, let's do this first. Let's just multiply across the tops and the bottoms. No common denominator needed. And then I'll reduce and I'll show you the cross-canceling. But if I multiply across the tops, 5 times 6 is 30. 2 times 1 is 2. And so I get 30 divided by 2, which is 15. So that is one way to get that answer. Again, no common denominator was needed. Another way to do this problem, we said, was to use cross-canceling. If I cross-cancel, hey, because everything's multiplying here, I can kill a 2, and that becomes a 1. And if I divide that by 2, I get 3. So now I get 5 times 3 is 15. Over 1 times 1 is 1. And 15 over 1 is 15. So either way I do it, I should get to the same answer. Bottom line here is, when you're adding, subtracting, get a common denominator. If you're multiplying, you do not need that, and you just multiply across the tops and the bottoms. All right, let's apply this now to today's rational exponents. All right, so here we go. We want to simplify these expressions, and we want to write our answers in both exponential and radical form. Again, this is going to be very similar to day 2, where we're going to, do these exponent rules and properties. Our only difference now, though, like on day 3, when I get an answer with an exponent, I need to write my answer both in radical and exponential form. All right, so if I'm paying attention here, if I'm multiplying bases, my rule is I need to add exponents. If I'm adding fractions, I need to get a common denominator. This would be a way that we could show our work. And good news for us, in this case, we have a common denominator, so we can go ahead and we can put these together. Again, add the tops and the bottom stays the same. This is a perfectly good answer in an exponential form. Okay. Now we also want to write this in radical form, and this is where, again, like on a multiple choice test, things can get a little bit tricky. Putting it into radical form, the bottom number again is the radical, the top number is the exponent, so this is 5th root of 2 to the 4th, or if I simplify this is the 5th root of 16. And what I mean by, like in a multiple choice test, why this is tricky is all 3 of these answers are the same number, they're the same answer. But you could see any of those on a multiple choice test, and that's why we need to be able to go back from form to form, exponential or radical form. But those are all exactly the same. Okay, here we go with number 2. Now I've got a power of a power. So we have a power of a power we're going to multiply. Again, this would be a way for me to show my work. Now I'm going to multiply straight across. I don't need a common denominator. Again, if you want to, you could have cross-canceled or just multiply straight across and then reduce. And there's my exponential answer, 7 to the 2/3. Now I need to write this in radical form. And there's my answer in radical form. Again, the bottom number is the radical. The top number is the power. Again, really, I would say on a test, you probably can see one of those 2 answers right there. 7 to the 2/3 or the cube root of 49. Okay, moving on to number 3. Okay, for number 3 here, we are dividing bases. So again, whenever we're adding or multiplying bases, taking power of a power, all that kind of good stuff, dividing bases, the base always stays the same. All right, so my base stays the same. When we're dividing, I'm going to subtract exponents. I always tell my class, again, any work you can show me that you know you're doing, I can give you partial credit on a test. So I think that's a good step to show right there. Again, yay, these already had a common denominator, so I can subtract the tops and the bottom stays the same. And then make sure I reduce that, so 3 to the 1/2. And then we should know that when you have a 1/2 power by now, that is the same as a square root. So 3 to the 1/2 or the square root of 3 would be our final answer. Again, just make sure on tonight's homework you are writing answers in both forms. You really want to get comfortable writing things both in exponential and radical form. Okay, here we go. Next one, number 4. Again, I'm multiplying bases. So when I multiply bases, I have to add exponents. And I find if you worry about just one rule at a time, like here I'm just worrying about this rule that I'm going to add exponents, that helps to keep me from making mistakes. If you're trying to, worry about adding exponents and getting a common denominator and adding and subtracting numbers all at the same time, that's when you tend to make mistakes. Okay, so worry about just one thing at a time. Show your steps. All right, so I'm going to add exponents. The base stays the same. And now I need to get a common denominator when I add. So I'm going to multiply the first fraction by 2 on the top and the bottom, times by 2, times by 2, to get me 10 over 14. And now I've got my common denominator, so I can add those together, and we get x to the 15 over 14. Now I would try to reduce that, but you can't reduce 15 over 14. So I'm going to put this, that is an okay answer in exponential form. I'm going to put this in radical form, so this would become the 14th root of x to the 15th. Now we do have a slight issue here, is that Again, remember when we're simplifying radicals, if the outside number can go into the power, if the index number can go into the power, then this radical can be simplified. So like in this case here, there is a group of 14 that I can take out. So 1x would come out, and then I'd have the 14th root of x to the first on the inside. So this would be the simplified radical form. It would have to look like that. This answer is okay in exponential form. We'll leave it improper like this sometimes, but you might also see this as, again, x times x to the 1/14th, because technically this is more correct because this mimics our radical answer. Okay, so you might see it like this, x to the 15th over 14. You might see it as x times x to the 1/14, or x times the 14th root of x. And that's why this gets confusing, because those are three different answers. They look completely different, but they all represent the same thing, and any of those could be the right answer on the multiple-choice test. All right, and then I almost forgot to think about this here, but we should at least think about it. Again, we said if you have an even root, okay, if it starts out even on the inside and odd on the outside, then you need absolute value. In this case, I was odd on the inside, so I don't need that absolute value. But again, these are rules that we need to consider as we're playing around with this. All right, number 5, we are dividing our bases, so I need to subtract exponents. Again, the base always stays the same. Now I need to get a common denominator since we're subtracting. So again, what I would do is put the 2 over 1 to make a fraction, and then I'm going to multiply the top and the bottom by 3. So 6 minus 2 is 4 over 3. And so now that is my answer in radical form, or in exponential form. Now I'm going to put it in radical form. When you go to do this, again, I would stop right here. If you notice that the index number is bigger than the power, or again, if this is an improper fraction, simplify. Don't multiply out 5 to the 4th. That's going to make things way too hard. Just simplify right here. 3 goes into 4 one time, so 1 5 is going to come out, and then I have 1 5 left on the inside. So that would be my simplified answer. This is a good answer, and this is a good answer right there. Okay, moving on to number 6. This one looks crazy and scary, but it's really not that bad. Just remember to follow order of operations. You want to start in your parentheses, and you are going to divide those things first. Remember that when you are dividing bases, 27 over 1 is just 27. X to the 8th over x, I'm going to subtract exponents, so I get x to the 6th. And subtract exponents, I get y to the 3rd. Now, I'm really left with all this to the 1/3 power, which means the cube root of all of this. And so now I want to do the cube root of 27, that is 3. Divide, 6 divided by 3 is x squared. 3 divided by 3 is y to the 1st. And so now, again, this was not an even radical, so I don't need to worry about absolute value. And there are no fractional exponents, so this would be my one and only answer. Again, I only got 2 answers when we had a fractional exponent. In this case, everything went in evenly, so we're okay. That's my answer, 3x squared y. See, 6 wasn't that bad, but these are going to get more interesting as we continue along here. All right, but I'm going to follow the same things. On number 7, I would try to put everything inside together first. However, my bases are different, so I cannot combine those two things. So then I have to move on to my exponent. I'm going to want to raise everything inside to the 3rd power. And again, my advice to you is worry about just one rule at a time. Because I have a power of a power, I'm now going to multiply these. And that's going to give me 7 squared times 7 to the 3/6. Or when I simplify that, I get 7 squared times 5 to the 1/2. And that is my exponential answer, or 49 root 5 would be my radical answer. But I think these are the 2 answers that you would see. All right, on number 8 here, my bases are different, so I cannot subtract exponents. But hopefully you recognize that 16, so that I can do this, I'm going to multiply everything out. 16 is a multiple of 4, and I can rewrite this as 4 squared. I want to change the way that number looks without really changing the number. All right? Now that I have this, I could rewrite this as a power is 4 to the 6 over 4 squared. And now, because the bases are the same, I can subtract exponents. And we get 4 to the 4th, or 256. On number 9, another way we can use these properties is, like we said, we can't multiply square roots and cube roots together, right? But maybe if I write these in radical form, and so I said radical, I meant exponential form, maybe now we can put these together. The bases are the same, so I can add exponents. I got to get a common denominator. I'm going to add those together, and there's my answer in exponential form. Because I have a fractional exponent, I can write this answer both in exponential and radical form. All right, pause this video now and on your own try 10 and 11. Okay, boys and girls, here's your answer. Have a nice day.